see you again. Firstly, I'm going to explain something so that you don't think something's happened midway through. We had a recording problem when we did the live version of this presentation. So what I'm doing now is just recording a few of the early slides so we can patch it together, edit it together, and then we can put it out to people who missed the presentation on our website. So if you see me suddenly change shirt, it's not because I spilled soup on or anything, it's because we're switching over to the live recorded presentation. Anyway, today we are talking about BRE Report 187 and unprotected area limits in the building regulations. Yeah, I'm Trevor Clements, I'm the Head of Business Development for Hertfordshire Building Control, and I'm going to be joined by my colleague Les Ryder, who is one of our gurus on fire-related matters. So I'm going to be snorkeling around in the shallows, you might say, for a bit, and then Les is going to do take you on a deep dive and some of the more complex aspects of the subject. Start with a bit of background history. There's quite a striking image there, a famous painting. The very first regulations relating to fire spread between buildings followed a large fire in London in the 13th century, and King John issued some ordnance to prohibit roofs from being covered with reeds or rush. And then 400 years later, of course, as in the picture, we had the Great Fire of London, 1666. As many of you know, that consumed over 13,000 houses, 87 churches, and that clearly demonstrated a need for more legislation. And it led to the London Buildings Act of 1667, and that stipulated minimum separation distances and that raw materials should be brick and stone rather than timber. And an interesting trivia question that I'll put to you: what was the official death toll in that huge conflagration? Any of you pub quizzes might know the answer. Well, in fact, the official death toll in the Great Fire of London was 6 persons. So that's quite striking, isn't it? I'm sure there was a hell of a lot more than that perished, but possibly it was never recorded. But it's an interesting little fact nevertheless. Anyway, that's the history. And after 360 years of evolving regulation, the modern equivalent is requirement B4, external fire spread. And that says that the external walls of the building, as you see, shall adequately resist the spread of fire over the walls and from one building to another, having regard to the height, use and position of the building. And the focus today is on spread of fire from one building to another. Spread across the walls of the building, of course, that's a very topical issue following Grenfell, and you may have seen in the news other subsequent fires, not quite as awful as that one, that occurred to lower-rise flats and similar buildings, caused by fire spread across the face of the building. I think it's fair to say there's currently a lack of clear guidance for determining compliance in that respect. We can't just look at approved document B anymore. So hopefully the new approved document that's in the offing will give us a bit more of a lead in terms of that. Anyway, enough of that, I digress. Today we are focusing on fire spread between buildings. An image there, quite a recent image, just to show that fire spread can occur in adjacent buildings for various reasons. This is a fire that occurred on our patch in North Church in Hertfordshire in August of this year, and a fire emanating from an attached outbuilding spread into the roof via the eaves and then into the first floor, and that happened to 2 houses, causing major damage to them and a bit of minor damage to the 2 others that were attached. And it's interesting to note that that damage could well have occurred even if the building was compliant with the rules we're about to discuss. Possibly scope for non-combustible soffits. So what are the mechanisms of fire spread in more typical scenarios? I'll give my thanks to Les for sourcing and adapting this useful diagram that demonstrates the principles. I'm just going to strike myself up a pointer here. It's useful to demonstrate. So, so we've got a burning building there, and we've got some assumed fire loads and fire intensity, depending on the use of the building. And that's either a reduced intensity of 84 kilowatts per metre squared for offices, domestic, assembly and car parks, and a standard fire load for shop, industrial buildings and storage of 164 kilowatts per metre squared. And the aim, of course, is to space buildings from the boundary, there's the boundary, to prevent the radiated heat, there it is, from exceeding 12.5 kilowatts at the face of the opposing building, 12.5 kilowatts per metre squared, should I say. And that's the theoretical heat intensity at which wood exposed to it will reach a pilot ignition temperature in about 10 minutes. And that then will allow a burning ember, there they are floating over from the building on fire, that will enable one of those burning embers to start a fire through pilot ignition. Now, something important, I'm going to explain this slowly because it's an interesting concept. It's important to bear in mind before we discuss the building regulations requirements relating to unprotected area limits. By that I mean limits on the total areas of doors and windows that face a boundary. When we specify a boundary distance on the basis of approved document B guidance, we're basing it on an assumption about any building that is already in existence or may be built on the adjacent site. And the assumption used has been that the two adjacent buildings would be identical and be effectively mirror images of each other across the site boundary. In other words, the distance needed to the site boundary is the boundary distance A, there it is, which equates to half the separation distance to A. And 2A is the distance that is necessary to keep the radiant heat intensity at the face of the opposing building from exceeding that critical 12.5 kilowatts per metre squared limit. So all very well, but let's imagine a scenario where initially we get a small building, say it's a house and it's built on a piece of land, and the building regulations guidance based on the amount of unprotected area, i.e. windows, etc., in that elevation there, of course, facing the boundary dictates a distance of A from that boundary to comply with the regulations. And this, of course, is based on the premise that a similar scale building may be built on the adjacent plot that will have a similar boundary distance. So that a separation distance of 2A, the heat radiated from a fire from either building will not exceed that critical 12.5 kilowatt limit at the face of the opposing building. As I say, all well and good, but let's imagine a scenario where a few years later permission is granted for a much bigger building. We're going to call it building 2, and taking an extreme, maybe it's a large warehouse, it's a building with large volume fire compartments and a high fire load, and thus it's requiring a greater distance to the boundary when referring to the national guidance. There it is, building 2. Problem being that in using the mirror theory, the separation distance, i.e. 2 times boundary distance, there it is for the first building, but for the second building, it's going to exceed what is needed to restrict radiated heat from a fire in building 2 to 12.5 kilowatts per metre squared at the face of building 1. The building is too close. So whilst building 2 might on the face of it appear to meet the guidance in itself, building 1 is now compromised in terms of fire safety. So the rule to remember when looking at unprotected area limits is that where there is a significant difference in the size of the 2 adjacent buildings, then a fire engineering approach is appropriate when considering the boundary distance to the smaller building. Of course, there is a simple alternative rather than try and find a fire engineer, and let's face it, they're as rare as hen's teeth these days. You can always just set building 2 the necessary separation distance of 2B from building 1. So ignore the boundary distance and make sure you achieve that 2B distance and thereby achieving compliance that way. So I hope that was reasonably clear. Another anomaly I'll mention before we go into any detail is that the rules we'll be discussing were based on buildings that were not as well thermally insulated as they are now. And a BRE report commissioned by the government in 2015 advised that, as you see there, improving the levels of thermal insulation to those recommended by approved document L1A, Conservation of Fuel and Power in New Buildings, may lead to higher fire temperatures. These can be compensated for by reducing the unprotected area of an elevation by 70%. 70%, wow, that's quite a factor, isn't it? And it's worrying, isn't it, that nothing changed since that document was published, even though we recently had an amended approved document B published. So there you go. I don't know quite why there was no response to that that report in the approved documents, but maybe it's still to come. We will see. All right, enough of background. Let's discuss the actual requirements that determine compliance. One of the first steps we take when checking a plan in accordance with approved document B, or the BS 999 series, is to establish the fire resistance that's necessary. So dependent on height of the top or story or the depth of the bottom story and whether suppression by sprinklers are fitted to the building, we look at table B4, and that's the reference for determining the level of fire resistance needed. In other words, there's table B4, as we see here, a dwelling house with a height not exceeding 5 metres has a fire resistance requirement of 30 minutes. Little symbol there relates to the need for 60-minute fire resistance for a party wall. So there you are. We work out from that table what fire resistance is necessary. This table, table B3, tells us how the elements should have been tested. And we see there that in the case of a wall that's within a metre from the boundary, we need to test the wall from each side separately. Whereas if the wall is more than a metre from the boundary, the testing is from the inside the building only. And I've highlighted the letters REI there when we're looking at the minimum provisions when testing to the European standard. And they relate to R being resistance to collapse, E being resistance to fire penetration, and I being resistance to the transfer of excessive heat, i.e. the insulation value. In other words, these are the ratings when we're considering European ratings to BSEN 13501 Part 2. However, they are really the similar sort of thing to the old stability, integrity and insulation properties that are used in the BS 476 tests that were used for many, many years and still are. So knowing that, we can now look at how we define unprotected area. I did say it's windows and doors in an elevation, but it's a bit more than that. And it says that parts of an external wall with less fire resistance than the appropriate amount given in Appendix B, Table B4, are called unprotected area. We've just seen what the requirements are. So if you're not hitting those requirements, then we would call it unprotected area. And even if you do hit those fire resistance requirements, 13.7 says where a fire resisting external wall has a surface material that is worse than the S3D2 and is more than 1 millimetre thick, then that part of the wall should also be classified as an unprotected area. However, we only use half its area when we're doing the calculation. So you see there the B3S3D2 rating. That's the Euro equivalent of Class O when we were looking at the old BS476 Part 6 testing. The B relates to the combustibility class. The S is the production of smoke, and the D relates to the production of flaming droplets, and the lower the number, then the better. So in other words, what 13.7 says that even if the wall has the required fire resistance, you still need to consider any combustible claddings and factor those in, allowing 50% of the actual in the calculation. So diagram 13.1, and this illustrates the methods that I mentioned in Table B3. So in other words, we're close to the boundary. We're looking for a very limited unprotected area, very small amounts. As soon as you get away from the boundary, then you can have a limited area of unprotected area. And then there comes a point when you've got a distance whereby the whole wall can be unprotected area, no provision at all. I say that, but the wall might need fire resistance because it might be supporting a floor, so it might be an element of supporting another element of structure that itself must be fire resistant. So it's not, you can't necessarily no fire resistance to the wall. Yeah, so that's that. Move on to the next slide. Unprotected areas that can be ignored because we don't have to include every single window or whatever or surface as being a risk in terms of fire spread. So this slide is just showing you that roofs less than 70 degrees pitch can be disregarded. So the nice shallow roof bungalow on the left. In fact, most roofs, of course, are at less than 70 degrees, so we don't include them. But just occasionally we get a mansard roof like the one on the right, and because that's over 70 degree pitch, we have to include it in the calculation, along with those dormers, of course.
Just interrupt you there, Trevor. So Les is in and has been listening. I don't know if you want to, Pastor, are you going to continue, or do you want Les to come in as well?
That's great timing to hear that. I'm absolutely delighted and relieved. Les was going to be taken over in a few slides. So hopefully he's good to go. I'll finish on what I was going to present, and then I'll do a handover, and we'll get in.
Okay, no, I'll make Les the host. All right then. Okay,
thank you
for
that, Rachel.
All right then. Thanks.
Okay, just carrying on with the last few slides before we get into the guru stuff, and other unprotected area that can be ignored, shown in diagrams in the approved documents. So first we can see that the grey shaded area, that's unprotected area that's enclosing a fire separated protected stairway. In other words, this is theoretically a fire sterile area, so we don't have to worry about any unprotected area in that section of wall. We've got 3 examples of areas in the key. So we've got these which represent unprotected area not more than a square metre, and that may consist of 2 or more smaller areas that together don't aggregate to more than 1 metre by 1 metre. So that they're the diagrammatic representations for the larger areas, and then these are small areas that don't amount to more than 0.1 metres squared. And with all these, there are minimum separation distances that need to be observed. In other words, the dimension A, which is 4 metres, the larger areas need to be at least 4 metres apart, horizontally or vertically. And the small areas, dimension B, need to be 1.5 metres apart. If they're not, then you can't ignore them. You have to consider them. The other rule there, you'll see I've shaded pink the compartment walls and compartment floors. Let's say it's a block of flats, and of course that would consist of 1 hour compartments. We consider each compartment separately, and we don't worry about the dimension across a line of compartmentation. So dimension C there, that can be, there's no limit, minimum limit placed on that. So hopefully that's clear. And yeah, so if those areas can be ignored, that's fine. And that's why when we're looking at buildings closer than a metre to the boundary, you're at the very least allowed the 1 square metre area, because that is an area that could straight away be ignored. But you're not allowed any more than that when you're within a metre of the boundary. Les is going to go into more detail on all this, but I'm just going to go through the simpler of the methods. There are 4 common methods for calculating the required boundary distance that are in the building regulations and associated documents. Method 1 is in ADB, and that's just a simple table. It relates to small residential buildings, not more than 3 stories and 24 metres in length. We've got method 2, also in approved document B. This is called the enclosing rectangle method, and that covers other buildings up to 10 metres in height, and but excludes open-sided car parks. Can't include that in that method. There's methods 3 and 4, 3 being for being based on BRE 187, 1 being enclosing rectangle, a slightly more finely tuned method, and 1 called the aggregate notional area, affectionately known as the protractor method, that a lot of people know about, but few have actually ever undertaken. And you're going to learn about those in the following slides. So, certainly when we're checking unprotected area in a design, we may check using method 1. If it doesn't work, we will use method 2. We might then ask the designer to say, right, well, you need to present to us a method 3 or 4 assessment to demonstrate compliance. Here's method 1, really simple table. It's just a case of checking that the area limits in the table aren't exceeded depending on how close the wall is to the relevant boundary. So in other words, as we can see, at 1 metre, if you've got at least a metre distance, then you're allowed 5.6 metres squared. As soon as you get over 2 metres, you're allowed 12 metres squared. So, and so on until you get to 6 metres, and then you've got no limit on unprotected areas. And you'll note the phrase relevant boundary there, minimum distance to the relevant boundary. The question is then, what makes that boundary relevant for consideration, you know, in relation to that boundary, in relation to that elevation? I'll quickly go through a slide to show you that. A relevant boundary might be a simple parallel boundary, as in A and B in the diagram, that one and that one. If it's an angle, and that angle is less than 80 degrees, then it's also relevant. So as soon as that angle is less than 80 degrees to the elevation, we have to consider it. And the way we do that is we take the closest point to the elevation, which in this case would be there, and that is the dimension we take when we're referring to the tables. That's quite onerous in some cases, because in that elevation you might not get any unprotected areas, you know, for a metre or 2 into the building. So I personally think, and some surveyors who are watching might disagree and may want to chip in later, that you can say, right, if that's the point where the first unprotected area occurs, then we can take the distance to that point there rather than the distance to there. Because all this might be, you know, 1 hour plus fire resistant masonry, which, you know, clearly is not really going to contribute anything to the market. For an elevation fronting a road, as a lot of people know, if it's a road, it may be a river, it may be a canal, there's not going to be any development there. So we can take the relevant boundary as being to the centre line of that feature. And you could also use that principle if it's a shared drive between two houses, which set into the deeds, nobody's ever going to develop on that shared drive, then you could take the relevant boundary to the centre line of it. You may have also heard the phrase a notional boundary, and we use that where there are more than one building on a same site. So not where you've got houses with distinct boundaries, but maybe it's an industrial estate or something like that, or a hotel complex without buildings. And that applies when at least one of the buildings is within the residential or assembly and recreation purpose groups, or it's going to be operated or managed by different organisations. And in those situations, we say that a notional boundary exists, and it's an imaginary line between the two buildings, and that line is set at a distance such that both will comply with the unprotected area limit. In other words, it is within the allowable limits given for both opposing buildings. And as long as that's the case, then the buildings will comply. And in a domestic situation, often it's overlooked that these notional boundaries can exist because you might have a non-exempt, you know, a large shed or a garage over 30 square metres, so it's controlled under the building regulations. Maybe it's a car barn. They're quite popular on housing estates now because they're quite compact in space-wise. And if they're in proximity to the main house and don't achieve the minimum fire resistance, then, you know, you might have to assume a notional boundary between them, as in this diagram. In this case, it's a dwelling house. You've got a small, or not a large garage. Obviously, it's a semi-detached garage over 30 square metres facing the dwelling. So you have to run the calculation for that elevation and make sure, you know, and that elevation might have a door area or something like that. So that there's a risk of fire spread between those two buildings. As I say, occasionally overlooked. And finally, from me, method 2, which is in ADB, it's another relatively simple calculation process that you might go to if method 1 doesn't show compliance or can't be used because the building isn't suitable for that method. And with this method, we look at the total unprotected area expressed as a percentage of the total area of the elevation. And then we've got a table in approved document B that shows the required boundary distance, and that depends on whether it's the lower or higher fire load. So the less onerous case, you're allowed a greater percentage closer to the boundary. So there's the maximum total percentages for a 24/60, and there's the minimum separation distance, boundary distance that you're looking for. As I say, more onerous for the higher fire load buildings. So in this instance, we need 15 metres for the higher fire load, whereas we only need 7.5 metres for residential buildings, based on a maximum percentage of 60% of the enclosing rectangle. So that's me done. I'm going to stop sharing now and hand over to Les, and we'll try and do that as seamlessly as possible after this morning's little, hopefully a bit. Yeah, look at that, straight in. How's that? Fantastic.
Yeah. Let's hope so. Let's see if I can share this screen, Trev. I think that's half the battle with this. How's that? Is that looking good?
If you press run and then go to your slide, I think you're in business, Les.
Can you see the
Sharing, yeah.
from current slide?
Yes, I think if you run.
Is that up and running? Can you see the slide?
Rachel, are you there? Can you see the slide?
We can see the slide.
Yeah, I can see the slide. You've got your all your screens down the side as well.
No, it's not. Yeah, try clicking run slideshow, Les, and then hopefully we'll get started. Either that or yeah.
It says I'm share. You are screen sharing. It says that.
Les, you might need to click the enable editing button first and then press the run slideshow.
I don't understand what you're saying because I've got a.
Did you see the yellow line at the top says enable editing in it?
Yes.
Click that. And then go back to sharing your.
I've got your screen now.
So go back to share screen.
Oh my God. Let's look. Share.
Yeah, looking good.
And now do the slideshow.
Is that it?
And now go to slideshow and do what you did before to press to make it go.
To make it go.
And run the slideshow.
See, it's so much easier on an iPad.
Yeah, or from current slide. Click. Yeah.
Slide, and I want to be clicking back, don't I?
We're good, Les?
Yeah.
Not as seamless as I had started to think, but we're there. I think you'll take it away.
Brilliant. Now, I don't think there'll be anything more silky or smooth than that, Trev. Right. Okay. Here we go. Let's see if we can get into the nuts and bolts of it. There you go. Trevor's identified 4 methods. There's actually 6, which is crazy. But there's 3 levels There's 3 levels of fire safety in ADB, BS 9999, and BS7 for whatever it is, the fire engineering approach. So there just seems to be a habit of making. If they've got a problem, let's find 6 solutions to it, and unprotected area is one of them. We're going to concentrate on methods 3 and 4. Obviously, there's not enough. I haven't got the expertise to run you through the fire engineering approach. But the reason why there's 5 methods is predominantly because, like what Trevor earlier said, you start off with method 1, and if method 1 doesn't work, you try method 2. And you're going to find out in a minute method 2, nowhere in the world that method 2 works. I think they made a mistake on method 2, but we'll run through that in a sec. Then we've got the enclosing rectangle, and there's 2 methods there. One's graphical and the other one's got tables. We won't do the graphical one. We've actually developed a bit of software to do the graphical version. And when we get that fully checked out, we'll issue it out for use, but it's not really checked yet. And method 4, the aggregate notional area, which is absolutely ideal for sloping boundaries. So that's the reason why there's 5 anyway. You start in method 1 and you get all the way to method 5, and if method 5 doesn't work, then you've got to literally reduce your unprotected area. It's all down to fire loads, just the same as buildings. It's down to impose loads, for different impose loads for dwellings, for shops, for flats, for industrial buildings. Fire loads is exactly the same. And in ADB terms, they're related to the purpose groups. Now, as far as separation of the boundaries concerned, there's 2 fire loads that pertains. The first is the reduced fire load, and that relates to domestic, office and assembly buildings. and open-sided car parks, we just found out a few days ago. And the second one is the standard fire load, which is basically what all the testing was done to. And those are the two heat fluxes that relate to each one. And if you did the fire dynamics session that we did a few weeks ago, you'll understand all about that kind of stuff. And the missus has started cooking and using the microwave exactly when I've started to present. How good's that timing? Anyway, I'm fully embarrassed. That's job done. Right, okay, well, in the old days, they were, the purpose groups were designed as a relation to kilograms of wood in the compartment. And the cut-off point for those two loads was 25 kilograms of wood in old money. But now, obviously, is in megajoules a square metre. The cut-off point, 525 megajoules. Is below that's a reduced fire load, and above that is the standard. And you get there's a table there that kind of gives you some fire loads there of basic buildings, give you an idea. But the upshot of that is there's two different fire loads, and you'll end up with two different distances to the boundary when you do the calculation, and we'll identify how to split them. Right, all the assumptions that relate to this particular requirement, guidance, I should say. And first of all is the fire involves a whole compartment. Obviously it doesn't in the photograph, because I think Matey's plasterboarded over his window or put a cupboard next to it, so that bit's not on fire. But theoretically, the whole compartment is assumed to be involved in the fire. All of the openings are assumed to be compromised. So all of the windows would look like that photograph where the fire is venting out through the window. The fire's flashed over and fully developed. And again, if you've done the fire dynamics session, you would know exactly what that relates to. And the temperature in there for the reduced fire loads assumed to be 830 degrees, and for the standard fire loads, 1040. But like Trevor said earlier on about this business of insulated compartments, all of the data that we're going to use was developed a million years ago, back in the 50s. And all of the testing was done in concrete compartments. Now, again, if you've done the fire dynamics session that we did, you would understand that the thermal inertia has got a lot to do with the temperature of the compartment. And if the compartment's fully insulated, the heat can't escape. So the compartment fire will get hotter. And that's the reason why that document said, well, you may have to reduce the unprotected areas for anything up to 70%. Because the temperatures for domestic properties are not 830 degrees anymore. They're fully insulated at the compartments, and plus the windows aren't small anymore. People don't want properties with small windows. So the compartment sizes, and even the BR187, it says that the whole situation really needs revising, but we stuck with it and we're going to work with it in the meantime. This is a bit from the fire dynamics thing. This is a bit about the fire curve. The fire starts slowly, hits flash over, gets into a fully developed stage, and burns out. And that temperature, dependent upon whether the fire load and the ventilation, for the reduced fire load it's 830, and for the high fire load it's 1040. Just a little ditty in there. Again, the assumptions in the calculations, the whole compartment's involved, all the unprotected areas are failed. There's radiant intensity from all unprotected areas. Remember, you probably won't remember, but we're talking about 84 kilowatts a square metre and 164 kilowatts a square metre, depending upon the fire load. It's the arbitrary fire load. No science involved in it anymore because it's all fashioned. But we stuck with it. No considerations taken for wind conditions, which can make a massive difference when it comes to fire spread. It tends to overestimate the distances to the boundary, and this is probably why after that document that Trevor mentioned about the 70% decrease in unprotected area, this is probably why they never did anything about it. They probably thought, well, it was a bit over the top to begin with, so let's not worry about it too much. And that's the only thing you can't bring a document out saying that the unprotected areas are excessive due to the insulation of the compartment and the sizes of the windows, which increases the ventilation and hence increases the temperature of the compartment, and then say, but we're not going to do anything about it. And that's the only reason I can think, is because the distances are a bit OTT. And 1 decimal point's good enough for the accuracy. You don't need to go mental on it. And in some cases to the nearest meter. And you will get, in the last 6 months, I've had some of the most varied ways of calculating unprotected area I've ever come across in my life. But you know, that's life. But like I'm saying, once it's into the right field, you know, we know we're going to be okay. Tight sites in the cities. This thing, unprotected area, revolves around compartmentations. It's what it's saying is, if you can't reduce the compartmentation, then you need a fire assessed risk engineering approach. Now, there's one other alternative on there, is to sprinkle it. So if the sprinklers are in accordance with I can't remember the number. I think it begins with a 5 or a 9 or something like that. So I don't worry about that. I worry about that when I need to open it up and read it. Don't try and carry numbers like that around in your head. Just be aware of them and be aware when to find them. You're far better off having the principal knowledge than walking around being an encyclopedia of standard numbers. So again, sprinklers can make a difference. We'll have a quick chat about that as well. So what we're going to do, we'll do the enclosing rectangle method first, probably the most common method. It's been in there since 1965, derived from data in the 50s. And I've got to move Trevor's photograph out of the, out of the way. There you go. You're at the top right-hand corner now, Trev. It involves the smallest predetermined size of rectangle enclosing all of the unprotected area of the compartment. Oh my God. I didn't even understand that when I read it. So, but you're going to get the idea. So, and it would have been a lot easier if I'd had my iPad, because I would have shown you a little bit. Well, the next slide, hopefully, with a bit luck, I can't remember what the next slide is, but with a bit luck, that will identify that. And you calculate the area of the unprotected area in relation to the enclosing rectangle. So if you've got 1 square meter of unprotected area and your enclosing rectangle is 10 square meters, then it's you're 10%. So it's relatively easy. What I was going to do on this slide with my iPad was to actually draw where the enclosing rectangle, the minimum enclosing rectangle would go. But it's a rectangle that goes from the top left, the window on the top, on the left-hand side. That's a point, and the top right-hand side.
I think you could lose a pointer if you. I think if you your menu, you could do what I did. Use a pointer and with a pen logo.
If I lose this screen, who knows?
No, you'll be right. Just click that pen logo and you'll be able.
Can you see my iPad? Can you see my what they call point?
Yeah, I can see that, but you could.
Yeah,
go with that if you want.
I might not get back in, Trev. That's what I'm panicking about.
It's just a tool, but okay.
Yeah, so it starts there. That's another point. It goes all the way down to the floor because of the door, and then back around again. And that's the enclosing rectangle. That's what it's doing. It says what it says on the tin. Now that's the minimum enclosing rectangle, but it gets a little bit trickier than that, because the rectangles that we use in the tables are all at 3 meter intervals. So it'll be so if that there is 10 meters by 5 meters, so 10 meters wide and 5 meters, then the smallest enclosing rectangle that we're going to get into that, and I have got some diagrams of this, so in case you don't pick this up, would be a 12 by 6 rectangle. I wish I had my pen. That slide was there specifically so I could do that. Those are all of that's one of, it says table 2 of 8, but it's actually 2 of 10. That's the size, the unprotected rectangle tables. I just wanted to show you that quick because we're going to go back to it. But basically, you can see that the width of these, the height of this enclosing rectangle is for 6 meters high, and it can be 3 meters long, 6 meters, 9 meters, 12 meters, etc., right up to 130 meters long. Now here is, I'm going to move Trevor's photograph to somewhere else now. Here's an example, and this is the data for the examples. Now, like I said, there's 2 enclosing rectangles. You remember that method 2 that Trevor showed you? Method 2 is just the enclosing rectangle around the unprotected areas. If you look at those 3 windows, those 3 glazed areas, I should say, those 3 glazed areas are unprotected area. The cladding of the external wall that you see there, that's non-combustible. That's an aluminium cladding with a non-combustible core, and it's got a block wall in behind it, which gives the 1 hour's fire resistance. So it's got the fire resistance. The cladding is non-combustible because, as Trevor said, if you remember, if the cladding is less than Class B, then we must take half of that as unprotected area, but we don't have to do it. Now, what I've drawn there is 2 enclosing rectangles. The black line is the enclosing rectangle for method 2, and that would be 12.8 meters by 3.12. The reason it's 3.12 is because that's the height of that glazing unit, and that glazing unit there, 2 and 3, is only 2.7 high. Now, the BR187 enclosing rectangle is the smallest rectangle in 3 meter increments that can enclose those unprotected areas. Now, that then turns into 12. It's a 12 meter long unprotected area is not big enough because it's 12.8 from side to side. So the minimum rectangle along the base is 15 meters, and because the glazing height is 3.12 meters high, it can't fit into a 3 meter high rectangle. So you've got to use a 6 meter high rectangle, and this is where you get a little bit of leeway on it. So the data that we referred with, the important data on that diagram is A, it's a shop and commercial, so it's a standard fire load. That's the first thing. The second thing is it's got 60 minutes fire resistance because of its purpose group, its size and its height, which Trevor again went through. The bits that we're interested in is the unprotected area. 1, 2 and 3, those 3 areas will not give 1 hour's fire resistance, so by definition they are unprotected areas. Okay, so now we took them up. So number 1 is 16.75, number 2, number 3, and we eventually get a total unprotected area of 37.17 square meters. That's what's relevant here. Then we've got those 2 conflicting enclosing rectangles, and that's going to become apparent in a second. Now here is method 2, and method 2 gives us, I'm going to move Trevor's photograph again. You
can click it, Les, and lose it all together. Not that you'd want to, I'm sure, because it's a fine thing, but you click your hide thumbnail button, you can I won't excuse.
You minimise it, but I like seeing your face, to be fair. I like seeing.
Most people feel the same, I'm sure.
Right, but this is method 2. Remember, this is the tight enclosing rectangle method. And so remember from the previous page, the total unprotected area is 31.17. The tight enclosing rectangle is 12.8 meters long and 3.128 meters high. And if you divide one by the other, you get 90%. Now, if you go back, if we go back to, that wasn't supposed to happen. That wasn't supposed to happen. If we go back to Trev's slide, where is it? Is it that? It's not that one. It's the one just before we, yeah, that one. You go back to, if you go into this slide, now we say maximum. If we look at the 2 columns, the first column is purpose group residential. So that's the reduced fire load. The second column is the standard fire load. That's the one we're talking about. This is a shop, as I said, and we've got maximum percentage of unprotected area. Now it's between 80 and 100, and that is between 20 and 25, so 90%, even I can interpret off the top of my head, will be 22.5 meters to the boundary. Now, I think they've screwed that up, because what they do say is that the total, if we go to 0.4, total percentage of unprotected area is found by dividing, etc., etc. Now, that's what we've just done. That gives an insane amount of unprotected area. We're going to find out that doing it the other way gives about 40%, and that gives 10 meters to the boundary. It's still a lot more than what we're going to do. We're going to ascertain from the enclosed rectangle. But I think they might have made a bit of an error on this method too, because it's insanely over the top, and I don't mean slightly over the top. I mean insanely over the top. Right. Let's get back to our slideshow from current slide, and we're going to go on to. So that was that table 13.1 in approved document. That's given 22.5 meters to the boundary, which is absolutely insane, but that's what it says. Now what we're going to do, we're going to do it on the BRE 187. Now remember our 3 glazing areas. Our 3 glazing areas are 1, 2, and 3. That gives 36.17 square meters of unprotected area. Remember our enclosing rectangle, the minimum that we could get round it. I should have drawn it in, but I thought I was going to have an eye pen, but I don't have an eye pen. Now that enclosing rectangle, the smallest enclosing rectangle on BRE 187 is 15 by 6. It's 15 by 6. Now I think I've lost some data off this slide. Basically, if we now divide 36.17 by 15 times 6, we get 40%. And again, this is, I should have changed this as well, because that should say 5 meters, not 5.5. And I'm going to show you why in a second. So, yeah, let's have a look at the next slide. No, it isn't. So imagine on this slide that unprotected area is going to be 40%. We've got the enclosing rectangle. We've got that yellow enclosing rectangle that goes round it. That's the 15.6, right? And those are the 3 areas. So when you add up 1, 2, and 3 and divide it by that area of unprotected area, you actually get 40%. Now, when you look in the tables, where that table was that behind? It was behind me, wasn't it? So if we go along, we've got a 6 meter high enclosing rectangle. It's 15 meters. Oh no, it is right. It's 15 meters long, and we go along. And what I was saying about the two fire loads, the standard fire load is without brackets and the reduced fire load is with brackets. So that distance to the boundary is 5.5 meters that we need. So that's relatively how easy this is. It's just a matter of working out the percentage. You fit the unprotected area into the smallest enclosing rectangle that you can, and then make a percentage of it, like we've done there, like I didn't do there, but it should have been on the next slide. So that's effectively the enclosing rectangle in BR 187.
Les, can I chip in just briefly there, because it's a good time to mention this anomaly that I've often noticed and couldn't work out. If you had something that didn't comply for boundary distance, you could possibly make it comply by actually increasing the unprotected area so that it increases the size of the enclosing rectangle that will fit it in the tables, thereby making it comply. Do you see what I mean? Because
yeah, I've tried that before, but the next table up takes that into account. So if, say, for argument's sake, we couldn't squeeze it into a 15 by 6, we needed to squeeze it into a 15 by 8, then yes, the percentage would go down. But if we went into an 18, in this case, it doesn't make any difference, to be fair. So in this case, you're 100% right. You could increase the size that, you know, you could put a little bit of unprotected area that was not area that you had to forget about. And so in this case, it's not that critical, because you can see that the 40%, whether it's for 18, 15 or 18 meters, it's still the same. You know, so that kind of area, obviously, they're not too concerned about. But yes, you're 100% right.
Yeah, because the 40% could then go down to 30 or less. Going into the bigger enclosing rectangle. So just an interesting.
I think it's a case on all. It's a case on all guidance. You know, that it doesn't take long to figure out, oh, there's a bit of a problem on this.
Mm.
And this is this method is even more prone to playing around with it, as I'll explain in a minute. Now, this is the most advanced way of ascertaining distance to the boundary in accordance with BR 187 that isn't fire engineered. And it's based on it, because basically what it is, it factors the UPA in relation to a chosen datum. So if you're stood on any part of the boundary, then it's, well, how much heat flux would you actually be exposed to? And that's what this is what this system tries to achieve. And it's a little bit tricky to get your head round, but I was doing these in the 70s when my district surveyor might be out on the district, and he'll just say, oh, sort out the unprotected areas on this, and I'd have to sit and work them all out for him, because that's what I did. In those days, we never got taken out on site until we'd been sat in the office for 3 years, you know, doing stuff like unprotected areas and stuff like that. So it was a common method. It was a common method in the 70s and the 80s. I can remember doing it quite regular, but it lends itself more to hard copies of the drawings. But this is the table that's been in the regulation since 1965, but obviously it was in feet and inches in 1965, but it's more or less the same. What it's saying is that if you've got if you've got a bit of an unprotected area between 1 and 1.2 meters away from the datum point, you've got to factor it up by 80. And if it's between 1.2 and 1.8 from the datum point, you've got to factor it up by 40, and so on and so forth. Now, it's not going to make absolutely zero sense to you, because you know, it won't. But basically, it's a factoring system. Now, what it lends itself to is a protractor. So what we used to have was sheets of tracing film with these circles all on the tracing film, and it looked something like that. Now, in this particular case, because if we go back to the table, we haven't got anything. We haven't got anything until these numbers here between 4.3 and about 8.5. So these facts are the only ones that we're going to be talking about. So I haven't got a 1 meter semicircle on the draw, 1.2 or a 1.8, otherwise it would have just made it even more busy than what it is at the moment. So what it says is that between anything less than 4.3 distance away from the datum, we've got a factor of 10. Anything between 4.3 and 6 meters, we've got a factor of 4, sorry. Anything between 6 and 8.5, we've got a factor of 2, and then after that we've just got a factor of 1. So now we can place this, or the designer can place this datum anywhere he wants, but he must move it 3 meters one side or the other and go through this process all over again. Now, as you can see, the lines of the protractor actually cut the windows of the protected area. So if we look at the glazed area in the center, we'll see it all fits into factor 4. And that's 3.57 in that direction, and it's 2.72 high. So if we go up to the table on the left, on number 1, which corresponds to number 1, we've got 3.57 times 2.72 high, and it's factored by 4, and that gives an aggregate notional area, that's where it comes from, an ANA of 38.8 square meters. Now, the second factor, like it does, it splits windows. So now what you've got to, and if you notice, it splits in factor 2, it splits 2 windows. So let's have a look at number 2. What I've done, what you'll notice is that the heights all stay the same. The heights will be constant. It's only the lengths that change. So what I've ascertained is on number 2, I've referenced that 2. That's 2.7 meters, 3.2 meters high, because that stays the same, and it's factored by 2. There's the factor 2. The next one is number 3, which is the one next to it. That's 2.7. 2.7 plus 2.7. Now, no makes 5.4, but I'm not going to argue over 30 millimeters. So don't bother writing to me on that one. So that's 5. So the number 3 is 2.7 times 3.12 times 1, because there's factor 1. And then we just continue that through all the way through, and then we eventually get 72.8 meters squared of aggregate notional area. Now, for the standard firewood, the maximum area is 90 square meters, and we've got 72.8 square meters. So this complies. Now, the difference between this and the other methods, or the majority of the other methods, you need to know the distance to the boundary, then you check it, which is basically the way that we do stuff. We check stuff, we don't design it. I would never turn around to anybody and say, oh, well, you need 6 meters to the boundary. They would send it in, and I would say, oh, it's, you know, this excessive unprotected area, you'll need either reduce it or do, you know, one of two things. So let's assume for argument's sake, and it's the case on this job, believe it or not, that we have a compartment wall that runs down the centre here between this window here and that window there. Then you would do it for each compartment. Remember, unprotected area relates to the compartment. It assumes the whole compartment is compromised by fire. So if the building is compartmented, then you would treat each compartment separately. And that was actually the case on this, because that's a mobility shop, that's a cafe, there's a compartment wall that runs down the middle, and then that's the bus terminal door, and there's a compartment wall there. So there's 1, 2, 3 compartment walls in this particular case, and which would mean that the distances to the boundary could be very, very short. This is the 5.5 is assuming that there's no compartmentation. The other thing that they could do if they were struggling, they could sprinkle the building. Now, if you sprinkle the building, you can halve the distance. So if that building, for argument's sake, if it wasn't compartmented, which in reality it is, but it wasn't compartmented, as the example shows, then, and we didn't have 5.5 meters of the boundary, we only had, you know, 3 meters to the end of the footpath, for argument's sake, and then there was a, you know, another building. Then sprinkling that building then would halve that distance. The other way of looking at it is if you've got a standard fire load, you can, if it's sprinkled, then you can halve the fire load. You can do it in either direction that you wish. But that more or less sums it all up. Time is it now? What we like for time? Computer's not working. 7:53. Yeah, that more or less sums everything. That was an interesting photograph, to be fair, and you wonder why. If for argument's sake, if that had been a ground floor flat and there was a first floor flat above it, then it wouldn't really make any difference how much fire resistance there was between floors. If the soffits weren't fire resistant, and yet we can't ask for the soffits to be fire resistant. So it's interesting that, you know, areas that where how fires behave don't necessarily reflect how we actually look at the requirements. Because if you looked at that, you would instantly say, well, you know, it wouldn't be a bad idea to have 1 hour fire resistance soffits and fascias, you know, to make sure that that fire doesn't compromise the unit above. But it doesn't work that way, and that's why the majority of high-rise fires occurs. They just skip around the compartment walls and go from opening to opening, which is not being considered yet. And it's part and parcel of external fire spread. External fire spread can happen in a myriad of ways that aren't controlled by the requirements or the guidance. Hopefully that gives you an idea, and if there's any questions, let them flow.
Thanks for that, Les. Yeah, we're a little bit off piece there at the end, which is good, and because that is a good point that fire spread across buildings is probably more critical in terms of life safety, and yet the guidance we've got to work with is so much more vague and needs to be sharpened up. You know, we saw the photo I showed of the recent fire in Northchurch, and that's exactly how the fire spread across the surface of the wall and up in the soffit, and had gutted 2 buildings as a result of that, and even though they were compliant in terms of unprotected area. So thanks very much. Thanks for the deeper dive. I tell you what, you audience, you're a brave bunch to, you know, this was really advanced training for building control personnel, and I did say, you know, please hook into it if you're interested. I hope you found it useful, but my goodness me, it was taking it right up to the advanced level in terms of knowledge of unprotected area and the building regulation compliance issues relating to that. So yeah, thanks for sitting through. Hopefully it's not fried your brains. Thank you very much, Les, as always. It's great to rely on somebody like Les with that advanced knowledge. Of course, if you ask him, he'll admit that I taught him everything he knows anyway, but
It's true, Trev.
if only. Do we have any questions? I don't know. I did offer up on chat. If there's any to put through very quickly, any chat questions before we wrap up, then please do it now or forever hold your peace, as they say. Maybe it's just everybody.
I think you're all falling asleep, Trev.
The aggregate notional area, that does it for most people. It's better than counting sheep, isn't it? Right, well, there you go. Okay, well, if there's no questions emanating, if anybody, obviously, any customers watching this, if you've got any questions on this subject, we're
One from Brian popped up, Trevor.
What's that?
The question in the chat from Brian Elborn. It says,
I don't see that.
oh, sorry, it's just sent it to me privately, but I'll read it out for you. It says, what do the regs require if you have buildings on the same site in the same ownership and the same type? Do you want me to read that again?
Yeah, no, I think I get that. So we're saying like an industrial estate where the buildings are, you know, maybe it's Airbus's premises where you've got industrial buildings in proximity to each other and they're all under the same ownership and management. And for that, if that is the nature of the question, I would say you don't have to worry about unprotected areas and separation of those buildings unless one of those buildings contains sleeping accommodation. It's only if they're in separate, managed under separate ownership, or they've got sleeping accommodation in one of the other buildings or both, that we would have to worry about unprotected area. Would you agree with that, Les? Would that be?
Yeah, absolutely. As I said, the 80 by 30 building at GSK that they're thinking about is slap bang in the middle of the site, and it wouldn't stand up to that kind of scrutiny, because it would need anything up to probably 20 metres of boundary.
So in terms of mandatory controls, there aren't any, because we concern ourselves with life safety only. But obviously, like Glaxo might think, well, for property protection, we're going to do something about that, and maybe put some compartmentation in or some sprinkler thing to just for their own purposes. But we wouldn't see it as a compliance issue. Hopefully, that answers the question. Was there anything else that submitted to you, Rach?
Nothing else submitted to me. No, please feel free to unmute yourself if you do want to, ask a question.
Yeah.
Can I just end on that, please, Trevor? If presumably, if those two buildings suddenly become owned by separate people, presumably you have no control over the fact that they're non-compliant.
That's an interesting one, Ian. Very interesting. Now, you could say that would be a material alteration, because any alteration to a building, even if it's an alteration to the use of the building, that has an effect on compliance of a fire safety issue, I think it potentially could be called a material alteration that would be controlled. So in which case we would, they would need to make an application to do that. And then we would implement those controls for building separation. Then less.
It's certainly a material. It's B4 is certainly a material consideration. It's material so it's a relevant requirement, isn't it?
Yeah.
So the second, theoretically, the second it makes situation worse, you could, if albeit it's not, it wouldn't be normal, but it could make the situation better. But I doubt it. But theoretically, it's something that probably never been considered before in the past. But it would certainly, you know, if you look at it in the strictest compliance terms, then yes, it would run plans to be deposited for it. Yeah.
Yeah. Thank you very much for that, Ian. That's a challenging one.
Yeah, that's got us. That it almost got us.
Yeah. Yeah.
I mean, it just makes me think that if somebody is buying a building in those circumstances, they would have to make sure that they don't have to, in crude terms, have to block up all their windows because they're, you know, a short distance away from the next door.
The worst, probably the situation where that could occur is a shock to office.
Right.
Sorry, an office to shop, because that would change the fire loads. So that you would go from a reduced fire load for the office to an increased fire load for the shop. And theoretically, you know, you could be in a position where, you know, well, you might, like I'm saying, I don't think anybody's ever considered it before in the past. But theoretically, you know, you could end up having to put sprinklers in, because that would half the distance, and that would get you back into the reduced, because that's what you're worried about. The only thing that could possibly go wrong is you move from a reduced fire load to a standard fire load, and under those circumstances, the quick solution will be to suppress the new premises.
Yeah, but I think the main point was the fact that two buildings that the use could be made continuous, the same, but the simple matter is that one, whether they're previously owned by the same ownership, they then become under separate ownership. So as under the one ownership they complied, under separate ownership they won't comply, because you have
of course, the notional boundary.
Yeah. So
same situation plus, isn't it?
Yeah, I'll perhaps research that one, but absolutely certain that answer's kosher. And if it's not, we'll send round a retraction and clarification. But that's our best attempt at that one.
Trevor, it's Susanna.
Hello.
Hello. That does also raise a question with the current government's plan to allow planning to open up for offices to be converted back to houses. That will certainly open up a lot of cans of worms for us when it comes to checking those houses.
Yeah,
it is an issue.
Offices are domestic, it's the same fire load, isn't it? So we wouldn't really have a problem on this side of things.
Well, even if you've got people sleeping in it, then?
Yeah, well, that's a different. You know, obviously the fire load stays the same, but the notional boundaries would, you know, that would kick in. And again,
yeah. Slightly different issue, but yeah.
Yeah, so consider when we assess a proposal to do that, and it's like the other, you know, we've got the unprotected, we've got permitted development relaxations on adding storage to buildings, which of course are going to cause unholy headaches in terms of suddenly we have to apply regulations that wouldn't have applied before, such as sprinklers and more enhanced smoke ventilation to those buildings, and I'm sure building owners think, oh, fantastic, I can realise some revenue here and increase the height of my building, without really thinking of the cost and complexity of adapting that building to comply. So yeah, it's good point, Anna. We'd have to take each case on its merits and make sure it complied in its new format. Yeah. Anybody else? Any last questions before we conclude? I've got nothing on chat. Nobody piping up. Rachel, have you got anything on chat?
No, it's nothing more from me.
All right. Well, Thanks again, everybody, for coming along for the ride. Sorry about the technical issues we had. We did, as I say, we did a dry run and it went off beautifully, but the gremlins were at us this morning at various times. But hopefully it didn't distract from your enjoyment of the presentation and that you got something from it. Probably more knowledge than you need, but then if you're a techie nerd like me, then that's no bad thing, you know, just learning about things that are possibly outside the normal remit of your role. So thanks to Les, thanks to Rachel for hosting, and thanks for joining us. Any questions ever that come up on this to customers and our colleagues, yeah, Les and I are both very happy to be contacted to help you out in that respect. So until the next CPD session, Rachel, what we got in the pipeline in that respect, just to remind people?
There's a presentation with Seeker, that's the next CPD,
Oh,
so
right,
that's
yes.
available on Eventbrite now.
Fine. So yeah, and you know, give us feedback on this and let us know if there are areas of, you know, technical knowledge that you think would be good to be covered in a future webinar, and we can put something together. As I say, that's for customers and our internal staff. So that's it then. I won't witter any longer. Thanks again, Les, and thanks to everybody for joining us. Hope to see you again soon. Bye for now.
Thank you.